Hi, my name's Kevin Bennison and I'm the lead trainer and managing director at SWL Training Limited here in the UK. Welcome to our tutorial and thank you very much for watching. So you may have watched our other tutorial on sling length calculation for balanced loads, and if you haven't, you may find it beneficial to do so just because some of the points covered in there do link into what we're covering in this tutorial. So what we're actually going to be covering is how to calculate the sling rating for multi-leg configurations. So firstly, looking at the method that we use for that. It's called uniform load method. Now that's a UK and European harmonised standard method of rating. Therefore, it's used by manufacturers and users alike. So you can research uniform load method. You'll find it in industry codes of practice, and you'll also find reference to it within manufacturers' documentation for things such as multi-leg chain slings. So firstly, I'd like to just look at why it's important to rate our slings correctly. To gain a greater understanding of how the angle of the sling affects the tension, we can lift this bar with a simple luggage scale. As you can see, the bar is suspended on one sling there, and at the moment on the luggage scale we have a tension of around 18 kilograms. Therefore the weight of the bar is 18 kilograms. So let's have a look how the angle of the slings then affects the tension. What we'll have now is the slings being used as a pair to lift the bar. Bearing in mind, with a load of 18 kilograms, the vertical tension on the two slings should be 9 kilograms each, 9 kilograms per sling. What we've got now is the sling length being equivalent to the distance between the slings. Therefore, an included angle of around 60 degrees or 30 degrees from the vertical per sling. But looking at the tension on the legs, it's not only 9 kilograms, it's actually greater than 10. So let's increase the angle. The included angle has now been increased to around 90 degrees. Therefore, a sling to vertical angle of 45 degrees on each leg. So looking at the tension this time, it has now increased to nearly 13 kilograms per leg, which is in line with our trigonometrical calculation, as seen by the calculator. 9 divided by cosine 45 equals 12.73. So let's increase the angle again. We now have an included angle of around 120 degrees. Therefore, 60 degrees sling to vertical on each leg. Having a look at the tension now. So we have around 18 kilograms of tension per leg. That is 2 times the vertical tension, which demonstrates perfectly why you need to pay attention to the angle when rating your slings. So with that sling tension in mind at the increased angles, it's important to rate our multi-leg arrangements accordingly. Now the manufacturer of, say, chain sling assemblies and multi-leg arrangements, they will already consider the angle deuce and the resultant tension, and they will have used, in the UK and Europe, uniform load method to state the working load limit for those multi-leg assemblies. So for example, if you've got a 2-leg, a 3-leg or 4-leg set of chain brothers, when you have a look on the tag or the associated information, it will give you the ratings for angle deuce for those number of legs. So it's important then to check the tag, have a look at the working load limit for the angled use, and don't exceed the specified angles. So what we are looking at here then, when we've got our individual accessories, such as, say, single leg flat webbing slings, or indeed any other type of accessory, that's rated in the vertical application. So we then have to work out what we can lift when we put them in a multi-leg arrangement, such as in a 2 or 4 leg arrangement. We're going to take what it can lift individually and then work out what we can lift in that configuration. So in accordance with the uniform load method, the way we do that is by using what we call mode factors. So the mode factor we're going to use is determined by 2 key things. So those 2 key things are, first, the angle of the legs. So we're going to use a table to assist us in doing our calculations. So we've got the angle as one of those elements. And the other key thing that we need to consider is the number of legs. How many legs are within the arrangement? So let's consider some configurations. If we've got a load, so we're just looking at a load side on there, and let's consider we were using 1 sling on that load. Now of course, when we used 1 sling, if it was vertical, its working load limit would essentially relate directly to how much load we can lift. So if you've got a 2-ton working load limit sling, that means if it's vertical, you can apply 2 ton of load to that sling. However, if we then put the sling at an angle, so let's say we've got 1 sling at an angle, and we're going to consider that we've got an angle there of up to 45 degrees. Now the thing about uniform load method is it takes away any complexity of what the actual angle is. We're just saying anywhere within 45 degrees from vertical. So as soon as you go off the vertical, anywhere up to 45 degrees, we're going to apply the same mode factor. So let's say we had that 45 degrees on 1 sling. We would actually be permitted to lift 70% of the working load limit. Therefore, 0.7 times working load limit. Now, it's not really a valid mode factor because of course, as you're aware, we can't use 1 sling at an angle. It's just going to swing and go back vertical. Therefore, to create our angle, we need 2 slings. So now what we're talking about is an angle of no greater than 45 degrees from the vertical. Therefore, relating back to our tutorial about sling length, an included angle of 90 degrees. So 45 degrees from the vertical. If you've got a balanced load, then we're looking at an included angle of 90 degrees between the 2 sling legs. So you've got a right angle. So thinking back then, if you pick the load up, you could actually use a credit card or just a piece of paper with a right angle on there to check that you're within that 90 degrees. Okay, so in that case, we've got 2 elements to that now. We've got 2 legs, and we have our angle of less than or equal to 90 degrees. So 2 legs, and we're looking at within 90 degrees. So if our mode factor would have been 0.7 ton for 1 sling, which isn't feasible, then of course for 2 legs it's then going to be 1.4. So what we're going to do is we're going to get what the mode factors are, and then we'll look at how to apply them. So that gives us a 2-leg mode factor within 90 degrees. So if we then move on to a 3-leg assembly, so let's say your manhole ring type load, concrete ring which goes into the ground, often lifted on 3 legs. So if you've got a 3-leg assembly, of course then, not exceeding 45 degrees from the vertical, that's moving on from our 0.7, 1.4, so in that case we're going to have a mode factor there of 2.1. So 3 legs within 90 degrees gives us a mode factor of 2.1. So then we've got a 4-leg assembly. So 4 legs on a 4-point lift, and same again, looking back again to our sling length calculation tutorial. Of course, it's important to bear in mind that diagonal distance between the diagonally opposite sling legs. So 45 degrees or less from the vertical, of course then giving you a 90-degree included angle across the diagonal. Now, you would reasonably assume that going on from what we've looked at, 0.7, 1.4, 2.1, the mode factor for this would be 2.8. However, it's not. The reason being is, as much as you try, you're unlikely to ever achieve even loading on those 4 legs. Think of a 4-leg table on an uneven floor. It rocks. You're not getting loading on 4 legs. So, to apply the same principles to a load when we're lifting it on slings, the only way to get even loading on the 4 legs is if the centre of gravity is smack bang in the middle of the 4 of those, exactly, and the 4 legs are exactly the same length. Well, think about it. When you hang up a 4-leg set of chains, or when you lay out 4 webbing slings that are, say, all 6 metres, for example, there's a manufacturer's tolerance on those straight away, and you'll often find that you're not getting exactly the same length on all 4 legs or slings. Therefore, you're not going to get even loading. The shorter one will take the load first. So you're not going to get the 25% share of load. So for that reason, and you'll find this with manufacturers' calculations as well, we essentially knock a leg off of that calculation. And our mode factor for a 4-point lift remains exactly the same as it is for a 3. So we've got a 2.1 mode factor there. So whether we've got 3 or 4 legs within 90-degree included angle, we've got a mode factor of 2.1. So let's have a look at then if we increase our angle. 2-point lift then, and the maximum legal angle for our slings. So you won't see ratings beyond then 60 degrees from the vertical or 120-degree included angle. And you would only go to that if circumstances dictated that it was absolutely necessary, because of course you're then increasing the stress on the load as well as the slings. So you would need to check that both the load and the slings were capable of that. But if you do go up to that, your mode factor is going to reduce. So we've now got 2 legs, and we're looking at somewhere between 90 to 120 degrees included angle. 2 legs, and our mode factor in that case is now dropping down to 1. The reason for that, thinking back to when we looked at our sling tension, when we were at that 120 degree included angle, there was twice the tension at that position than there had been at the vertical. So therefore, you can't lift as much. You can only lift half as much on each sling. Otherwise you're overloading the working load limit of the sling. So there we go. And then of course, looking at our 4-leg assembly, 3-leg would be exactly the same of course. So our 4-leg assembly, 60 degrees from the vertical, maximum on either leg, and 120 degrees across the diagonal distance. We're then looking at, it drops down from 2.1, you've got a mode factor in that case of 1.5. Okay, so now we've got our mode factors. It's looking at how to apply those. So how we use the mode factors. Well, there's 2 ways. We either start off with our sling to get up to our load that we can lift, as in our rated capacity or safe working load. So let's go that way. We start off with the working load limit of the individual leg that you're putting within that arrangement. So for example, 2-ton webbing sling, you're using a number of those together. Then we'll look at getting our mode factor in accordance with the number of legs and the angle. So we take the working load limit, multiply that by the mode factor, and that's going to give us the maximum safe working load, as in the rated capacity. So we'll look at a couple of examples in a moment, just so you can check the calculation. Going the other way, which is more likely during the planning phase or selection of suitable lifting accessories, lifting gear, slings, however you wish to term them. Okay, going the other way, we start off with the load weight. We then need to consider what configuration the accessories will be in. So back to number of legs, angle, and we're going to take the load weight and divide that by the relevant mode factor. The result of that will be the minimum required working load limit for the individual leg. So you might want to take those down and just pause, note them down, so we can apply the minimum load. So let's go through an example then. First of all, a couple of things we've got to identify: what accessories we're using and the relevant mode factor. So let's say we've got a 45-degree angle from vertical, therefore for a balanced load, 90-degree included angle. Okay, so clearly we're going to be here, we've got two legs, so we've got a mode factor of 1.4 in that case. Two legs within 90 degrees, we've got a mode factor of 1.4. Let's say we're using 4.5 ton working load limit slings. I understand generally we're looking at increments of 1 ton, but it's just to give you a better idea on calculating that. So let's just say theoretically we'll have two slings, each one good for 4.5 ton at the vertical position. So then we need to multiply that working load limit by the mode factor, which is of course 1.4. Now if you just want to take a moment just to calculate that, or pause. So the result of that then being 6.3 ton. That means that the maximum load weight in that case is 6.3 tons. Okay? Of course, if those slings were at the vertical, it would be 9. But using our mode factors, that drops down to 6.3 in accordance with uniform load method. So, taking a 4-point lift as an example. So again, we're looking at our number of legs, the angle, and this time we're going to go from load weight and try and work out what size sling that we actually need. So 45-degree angle we'll go for again from the vertical, therefore 90-degree included. And we're going to then, of course, we've got our mode factor of 2.1. We're looking then at our load weight. So our load weight is 9.5 tons. We've identified our mode factor within 90 degrees, 4 legs, 2.1. So in this case, we start off with our load weight, 9.5 tons. We're going to divide that by the relevant mode factor, 2.1. Okay, same again. If you'd like to just pause it, you can do and calculate that yourself. So the result of that then is a minimum working load limit of 4.53 ton per sling. Each sling needs to have a vertical rating of at least 4.53 ton to lift that load safely without overloading the slings in accordance with uniform load method. So there is of course the trigonometrical method of rating, however it's more complex. It relies upon you identifying the exact angle of the sling and then therefore working out the rating in accordance with the exact angle. So uniform load method, it just makes it a little bit simpler. Anywhere within 90 degrees, you're looking at either 1.4 or 2.1. And then between 90 and 120, you're looking at either 1 or 1.5. So, there we go. What I recommend you do is practice those regularly. Get out on site and start practicing them and get them stuck in your head. There aren't many mode factors to think about, so it's quite easy to get them in there and keep them in there. It may help you to perhaps go to the supermarket or indeed the stationers and get a little blank postcard. Write this table down, and then on the reverse side, perhaps write down how to use the mode factors. Then you can laminate that and put it in your pocket. And then you can pull out and refer to it whenever you're on site. But not just when you have to calculate it. Have a look at different loads and think, what slings would I use for those? Have a look at different accessories and think, right, what's the maximum we could lift in a given configuration? So this not only applies to the sling legs, it applies to anything within the arrangement. So if you had a shackle on there, for example, on the connection points, they would also be within that arrangement and have to be calculated accordingly. I hope you found this tutorial helpful, and thank you very much for watching. Please do get in touch if you have any questions about this or any other lifting matters. You can contact us through our website, swltraining.com, or through social media.